Hello everyone, my name is Oleksii Baranovskyi. I am a senior lecturer in DIDA department in BT Hall. And for today my first breakfast seminar with topic, as you see, Advanced Web Application Vulnerabilities, connected with our general PROMIS program, Professional Master Information Security. This is a comprehensive program integrated with business as well as academia, to achieve the best goals in the field of, let's say, in the field of secure engineering. We strongly believe that we should achieve the enough level of security of our products, of our software engineering, let's say, of our software environment, just with preemptive secure engineering, predictive secure engineering, but not focused mostly on incident handling and so on, so on, so on. For today, our agenda discussing the advanced web application vulnerabilities with maybe some examples from my experience as penetration tester and the forensic investigator. And we'll discuss, we'll clarify some questions about the general PROMIS project, our starting courses, and we'll give an information how to apply for PROMIS project. So, my agenda today starts from 4 chapters: myth, errors, examples, and education of advanced web application vulnerabilities. So don't take so much attention to this just for fun and a little to, let's say, to make our conversation more flexible as well as interactive. So if you will have any questions, do not hesitate to ask me in chat. Yep, I do believe that my colleagues will help me with questions, because I will move forward with our presentation. But if you will have questions, don't hesitate to ask. So there are several myths connected with inherent to nowadays web developers. What they believe in? They believe that the using of modern tested framework will cover any security issues. The second one, that modern protocols of communication between our web components could provide flexibility, resilience, and of course security of our system, of our general web system. Of course, for today we have a trend with MIAN framework. Looks like the LAMP, remember, Linux, Apache, MySQL, PHP. The same we have for today with MIAN, MongoDB, Express.js, AngularJS, as well as Node.js. The whole stack that based on one language, JS. And of course, that our developers sometimes believe that cryptography is very easy things, and SSL or TLS will cover anything. That's why we do not need to take care about this. According to this, security is a totally bullshit, and our system based on previous bullet points mostly safe and secure. So there are several myths that I would like to explain, maybe some break today, and so on. So first, E for errors. Yeah, definitely. I strongly agree that for today we have evolution from technical errors mostly to logical, because we have a lot of pre-developed templates, approaches, as well as frameworks, libraries, stacks, and so on. But for this approach, we also have a lot of inherent errors. For example, exception catching, or manipulation of parameters and input points. We have evolution of technology stack, but we still based on old-style protocols. Without a hypertext transfer protocol, we couldn't do anything for now, definitely, mostly. And of course, developers are still people. That's why they make mistakes. They, let's say, sometimes they could miss something. Sometimes they could forget about something, and so on. And I would like to mention that, honestly, sometimes shit happens. That's why we have we could have in very great built application a small input point developed by school guy or first-year students as coursework with technical mistakes as well. So I would like to show you several errors found by me and my colleagues during penetration test and forensic investigation. First of all, it's an example of incorrect protection mechanisms, in our communication. Look at this, please. Security calls it the situation that developers need to implement a CSRF token. I mean, protection mechanism from CSRF attack. Yeah, all right, they did it. They implement, you see guys using screen, Windows CSRF token, added to each request from client side to server side. Looks like everything is fine, but there was one big problem, that this code was placed not on the page, but on separate JS file. According to this, any attacker could request on their malicious web page this file from remote server, obtain this CSRF token from this JS file, and include it into the forged request from the browser of our victim. That's it. You know, one simple thing, the place of this CSRF token, not into the general page, but into the separate JS file. Yeah, it was more easy to generate it and so on, but as you see, it caused a mistake into security protection mechanism. It's just one simple example. Second one example comes with also human mistake. It was sorry about this. You see this writings because NDA and so on. This example comes from application developed by Mean framework, Mean stack. I annotated it before, and it was totally synchronous. It's okay, and developers provide general API with full description of method, functions, and so on. But was one great thing. The method named PDF writings developed to export export data into PDF format, calls it the 500 general server error. And after that, server did not answer for any request, had answer for any request. And it was denial of service. Why? Because developer forgot to realize this method, and they've forgotten to catch the errors. That's why, according to the nature of this server application, after uncovered exception, it ends its work. It provides stack trace and bye-bye. But the main idea here was not in uncovered exception and so on, cached exception and so on, but that developers tried asked us maybe 5 or 6 times to repeat this attack because they had no any information about the root cause of this incident. It means that in their system there were not enough logging and monitoring, I mean accounting. That's why, according to the AWASP AWASP top 10 threats, it was the 10 threats, insufficient logging and monitoring, because we were asked about 10 times to repeat this attack to give developers information about the root cause of this incident. It's the second example. The third one example was the third example also comes from a modern web application, and it calls it not one but 3 threads at the same time. The main idea of this thread was that developers use a JSON web application token to transfer the state between backend, I mean server application, and client application, front-end. Front-end was complex JavaScript application that received the states from the server and changed its behavior according to the state from server and so on, obtained from server. But it calls several threads with one main type as broken access control, the fifth place on Avast top 10 for now. First, an example. First, an example of account provision process. By the way, this point comes from Avast testing guide, a general approach provided by Avast project. So, account provision process. How it was? Any people, any user could obtain the could change their level just by placing just by changing. You see the administration nodes, administration rights to the local storage. Imagine client-side application changed its behavior and gives access to some administrative function based on information obtained not from server side, but obtained from local storage. And I don't know why, but developers believed that local storage is impossible to change by simple Chrome or Mozilla Firefox debugger. It was so easy that with this changing, we've got the total administrative rights on client-side web application. And what was so funny, that those requests generated from compromised front-end were accepted by backend, because this approach, this threat, as I said, broken access control, was faced not only with front side but back side as well. And we come from account provision to authorization schema bypass. How it was? It was very easy. This first image, you can see that it's just token obtained by simple user. Okay, we have, let's say, our login, we have several identifiers by region or user group, and we have user ID, and of course user email. Sorry, I hide it according to the policies. All right, for any user had a function to search for other users, and we could get the list of users by region, and of course obtain their ID. After replacing my ID with their any user ID, I will succeed to change its information and get access for resources owned by this user without any changing. Of course, it was authorization schema bypass caused by absence of GVT token checking. What does it mean? Token was connected just with the session started by server application server, not application. In this case, on applications on backside, developers just checks the presence of this token, and after that they serialize it and use their functions, but without any correlation with real session. There were no correlation with session ID and session user. And the third one also was caused by this threat, was privilege escalation. How it works, the same looks like as first account provision process. We could receive the permission for front end from the server, and we could hijack it with proxy, whatever, book suite or child's proxy, doesn't matter. Change any node to true, and get access for any administrative functions. By the way, it was also it was so easy to break this specific application according to the fact that it was not obfuscated. So it was easy to analyze JavaScript code and libraries as well, and understand the logic built into this code. So 2 points: obfuscation of the code and the absence of checking the content of GWT, JSON Web Token, and correlation of this token to the specific session. That's it. As I see, we have just GWT token as based on our HTTP protocol. Another one example I would like to show you started with the fact that for today developers like to develop everything in one language. What does it mean? That we have backend, we have front end developed by JavaScript, for example, in mean stack, or Swift in applications, Apple applications, and so on. So for this example, we will succeed to break the application, to break the web application, server-side application, with a very interesting attack named insecure deserialization. By the way, what does it mean? The main problem that our HTTP protocol transfers just text, and we need to transfer the states between client-side and server-side and vice versa with simple text. We need to serialize our object from memory binary to text and deserialize it. The same with not only with JSON but also with XML and other CSV, whatever. It doesn't matter. But the main idea that during the serialization we lose the attributes types, and we need to restore these attribute types during the deserialization. And it could cause a lot of very interesting logical vulnerabilities and weakness, and to be exploited by attackers. Look at this example, please. In this example, server-side code deserialize this object, but deserialize it in vulnerable way, and gives ability to create on server side a file named pivot.php with content system get exec. That's it. You know that remote server was based on Linux, and we were surprised that it used not only Vapor server Swift-based server agent, but also Jinx with supporting the PHP. According to this, imagine from one technology, Swift-based, we moved to LAMP-based technology, to PHP-based technology, and received access for server-side commanding. Example of insecure deserialization. And the last, the least but not last, that's all, example of multi-component information system. It's a very interesting attack that comes much more popular, became much more popular last years, named HTTP request smuggling. And this attack based on, the chain of servers, the presence of load balancing between several servers, or session spreading, so on, so on, so on, and taking into account that our HTTP protocol has a very interesting situation when we have fixed content length of our requests, and the flag, I mean the point that we chunk our request, with divide or split it to several packets. With this case, we could, for example, send one request starting from this one, continued with that one, that could be divided for two servers, and and proceed with those two different application servers from load balancing or ingress proxy and so on. So this could cause or cache poisoning, or for example request forging and so on. In this example, we split this request for two, notify the additional host, and receive the answer, you see, by one of the server that redirects the user to forged machine with combination of CSRF, or with combination with proxy, not proxy, but cache poisoning. It could cause a dramatic results. So there were 5 examples for advanced web application attacks. Of course, we have not so much time to cover a lot of additional interesting vulnerabilities and attacks that from our experience, but we do believe that if this was interesting to you, and it sounds interesting, you could take part in our PROMIS project that, as we said, focused on professional master information security and focused on individuals with existing experience. And of course, we do believe that based on our combination of efforts between academia as well as professional companies, we could deliver, let's say, really a comprehensive and advanced course of secure programming as well as web application development. For now, we could propose 3 courses, started with security in software-intensive products, mostly focused on managing of secure development, with taking into account security governance, risk management, and of course security economy, return of investment, and so on. I mean, to create an understanding of secure development process. Of course, we pass through the secure software course with low-level security description of low-level security vulnerabilities, buffer overflows, and stack overflows, heap overflows, so on and so on. And of course, describing and practice in how to conduct the threat modeling, how to predict the threats for specific software, and so on, so on. And the course, of course, we was faced with web system security, because for today a lot of systems are in the web, much more systems than the desktop. So we will cover a lot of topics with modern web application security, starting from servers, come through different types of applications with different languages, and of course the threats, the present threats for application, and methodology for testing, and as well as dynamic testing and static testing of code, to build our web application more secure and safe. So, you know, we will be proud if you will spread our information about our courses at your company. You could like our page and let's say repost it. Please do not hesitate to ask any question that you need. Create your account, search for courses, upload required documents, and I do believe that I will see you and you will see me in our next courses. So, thanks about this. I'm ready to answer for any of your questions.
I can add one thing about when you're applying for the courses. You need to have worked at least 2 years within the field of developing software-intensive products or similar like that. And so when you apply, you basically get an email from me or someone else in the project with this template that you can fill in, just signed by your company. So it's very easy to apply. And all courses will be online, running on 25% study pace, starting in September this year and ending in end of January. So we are looking forward to a lot of participants in the courses. Does anyone have any questions? We have the chat function as well. It's really great to see that there's so many participants.
Yeah, I could add one thing. We have a lot of people here, so if we have someone from a company who are not involved in the project, we are interested in having new companies involved in the project. This PROMIS project, phase 1, we will develop free courses, but we will also apply for phase 2, and there we will develop more courses. Totally, we will develop around about 15 to 20 courses to the industry. So this is not mainly for students, as you know. The foundation is to hide knowledge in Swedish companies so they have good competition on the international market. And the courses we will develop are not designed yet. So we could use some input from companies, what you need in the future, and give you an opportunity to help us in finding the correct courses. And also we need partners in those course developments. So feel free, if you don't want to say something, mail me or Anna or somebody else.
Yeah, exactly.
Yeah. So
we will also upload this presentation on our website, promis.edu.se. And there you will also find all the contact information to us in the team. Yeah, please, Oleksii.
yeah, thanks guys for your attention. I was proud to be here. So I do believe that we'll meet with our next, with our future seminars. I will describe the other part of my experience focused on forensic investigations. So take care and so on.
Thank you very much.
See you, gentlemen.